In this lesson, we're going to learn about the parallelogram. So first thing is the definition of a parallelogram. So a parallelogram is a quadrilateral with two pairs of parallel sides, hence parallelogram. So the opposite sides are parallel, and there has to be two pairs, because if there's only one pair of parallel sides, well then by definition this would be a trapezoid. So a parallelogram is a trapezoid because it satisfies the definition of being a trapezoid, but in order to be a parallelogram, you have to have both pairs of opposite sides being parallel. So some other properties about parallelograms, these properties right here: 4 sides, 4 angles, the sum of the interior angles is 360, the sum of the exterior angles is 360. Those are all true for any quadrilateral. So since a parallelogram is a quadrilateral, all of those properties still hold true. And then if we look at the bottom here, we have some additional properties that are unique to parallelograms. So a parallelogram has both pairs of opposite sides parallel, which we just talked about. And remember, to mark parallel, you put the arrows. And then also both pairs of opposite sides are congruent. So you, again, both pairs have to be congruent. And then we also have opposite angles. So our opposite angles, so this angle and this angle, those are considered opposite angles. They're opposite each other. Remember that the same side interior angles, so this single arc and this double arc, are going to add to 180. And the reason why that's true is because if these lines are parallel, then you have same side supplementary interior angles. So those will always add to 180, which is really what this property here is saying. So consecutive angles, or angles next to each other, or in a row, all mean consecutive. So these two angles are going to be supplementary, as well as if I were to draw in another pair of angles here, these are going to be supplementary, all because of parallel lines implying supplementary same side interior angles. And since you have both pairs of opposite sides parallel, you're going to have multiple pairs of consecutive angles that are going to be supplementary, or adding to 180 degrees. So it's not just those ones. You could also say, I'm going to just redraw that. I just want you to make sure that you see in a parallelogram, it can also be the angles down here that are supplementary, because both pairs of sides are parallel. So then the other one that comes up a lot is the fact that in a parallelogram, the diagonals bisect each other. So this diagonal and this diagonal, they're bisecting each other, which means that they cut each other into two equal parts. So these two parts are equal to each other, but not necessarily equal to these two parts on the other diagonal. And then lastly, in a parallelogram, one diagonal will always create two triangles. So in this picture, triangle 1 is going to be congruent to triangle 2, and you could use your properties of a parallelogram to be able to prove that. I mean, the easiest one is just to think, well, if opposite sides are parallel, or not opposite sides parallel, if opposite sides are congruent, so if those two sides are congruent and these two sides are congruent, and I have the reflexive property, right away you can see by side, side, side that these two triangles have to be congruent. So that's the easiest way to kind of justify that property. So those are all properties of parallelograms. Lots of different things to remember, but most importantly, the definition of a parallelogram is opposite sides are parallel. Both pairs of opposite sides are parallel.
For these examples, we're going to use our parallelogram properties on the previous page to solve. So the first thing is, let's just read through and decide which property would best be used. So two diagonals which meet at a point T are drawn in parallelogram HJES. So the first thing I want to do is let's just draw that picture. So I have my parallelogram, so this is HJES. Notice that I went around the parallelogram when I labeled it. Doesn't matter where you start with point H, but make sure you go around the parallelogram in either direction to label. And it says that there's two diagonals that are drawn, so two diagonals, and these meet at point T. And then it says the length of HJ, so HJ is 11. The sum of the total length of the diagonals, HE, so HE plus JS is 38. So I can't really label that in my picture, so I'm just going to write it there. It tells me the length of HT is 8.5. I want to find the length of JS. So my goal is to figure out the length of this diagonal. So the first thing is I'm thinking about which parallelogram property I should use. And since we're dealing with diagonals, the fact that the diagonals bisect each other seems like that would make the most sense to use as my property. So I'm just going to write that off to the side here. So I'm going to say since I have a parallelogram, that means that the diagonals bisect each other. And then I'm going to go ahead and mark that. So these two pieces have to be equal. So that means that this is 8.5. And then these two parts are equal. So now when I look at this, I know that this entire length of diagonal HE has to be 8.5 plus 8.5. So I can add those together. And we have 17 for that. So that means HE is really 17. So 17 plus JS has to equal 38. So that means if I want to find JS, 38 minus 17, we end up with 21. So the length of JS would be 21. And then if we wanted to find the individual parts, it doesn't ask for it, but if I wanted to find the individual parts, I could just divide that total length by 2, and each part would have to be 10.5. So notice in this problem, I didn't use that 11. So that was just a distractor. So be careful of that. Sometimes you'll be given extra information that isn't necessary to solve the problem. So just be aware of that. So let's try another example. So in parallelogram TREN, so let's start with our picture. So we have our parallelogram. And again, start your TREN going around the parallelogram. Doesn't matter where you start T. It says the diagonal RN is drawn. So I'm going to go ahead and draw that in. Then it talks about angles. So the measure of angle REN is 66. And the measure of angle RNE, so RNE is 63. What is the measure of angle RNT? So my goal is to figure out this angle right here. So right away, I'm thinking about a couple different things in a parallelogram. There's really a couple different ways that you could solve this. I'm thinking about opposite angles being congruent. So we know in a parallelogram that opposite angles are congruent. So that means if this is 66, this angle T is 66. And then I also know that a parallelogram gives me opposite sides are parallel. And the opposite sides being parallel aren't really angles, but I can get my angles from that. So parallelogram implies opposite sides are parallel. That's the definition of a parallelogram. And if we have parallel lines, well, now I see that Z shape. That implies congruent alternate interior angles. So I know that these are parallel. I also know that these sides are parallel. So if we look at the Z shape, I have this Z shape right here. So if this is 63, this one's 63. And then I could say, well, angles in a triangle, so these three angles all belong to that yellow triangle. So I could just then do 180 minus 66 minus 63. So I could subtract those. So 180 minus 66 minus 63, that gives me 51. So that would be the angle that we're looking for. So the measure of angle RNT equals 51. So that's one way, looking at those parallel lines. Another option would have been to not use the opposite angles or the 63 and just to look at it sideways. So basically look at this Z shape. And then I would know that these angles have to be equal. So since I knew the 63 and the 66, I could have said, well, those two angles, 63 plus 66, subtract those from 180, that would have gotten me 51. And then I would have said the opposite sides, RE and TN, are parallel, which then implies that these two angles here are congruent, so then they're both 51. So that would have been another option, a little bit shorter. But really with these problems, you're going to notice there's multiple ways of doing them. There might even be other ways that you're thinking about doing it. So lots of possibilities, as long as you're getting to the same conclusion and you're using the parallelogram properties correctly, you're not making up any of your own, you're doing it correctly. So just be aware of that. So go ahead and write down some key ideas, and we'll talk about these tomorrow.